Hey, hello. This is a brief little video about some C++ Arduino specific programming basics. We'll go over data types, variables, loops, functions. We'll kind of try to keep it as pretty brief, but we are going to go through some examples and hopefully you'll get a basic foundation of Arduino programming. So here's a little overview. We have the Arduino IDE, just kind of what it is, what language it is. Then we have the data types and variables, conditional statements and loops, arrays, and finally we'll finish with functions and libraries. All of these things we'll be using throughout ECE 5, specifically for the workshop and worksheet, but also for your robot later down the line and other labs. So let's get started. So what does a program do? Like, if you've never had any experience with it before, it might be somewhat unfamiliar, or maybe it looks like magic, like your robot or your board just started doing something completely random that you don't understand. Well, program is a set of instructions that tells a computer or a microcontroller what to do. That's basically what it does. A program can be flashed to a hardware device such as your ESP32, or it can run on your computer. It processes input such as sensors or other actuators that you might have attached to your ESP32. It performs computations and then it also produces an output. For some examples of this might be blinking an LED, which you might have done in a lab 0 if you've done this already, and then reading a sensor or controlling a motor, which are all things we will be doing throughout this course. So an example of a program and what it might look in Arduino specifically is here on this right side. We have our void setup, our serial begin, and then our void loop, which is reading a sensor, this guy here, and here we're using our analog read to specifically read from a pin, but we'll dive deeper into this later on. Okay, so what language are we using? Arduino uses a derivative or C++, I say, with a few tweaks. It makes it a little bit more approachable. They are simplifications, so if you just learn Arduino C++ and then go into C++, there are going to be some differences. Mainly, one of the key differences is in the Arduino IDE environment, we have this void setup and the void loop, and they must always be there. Even if there's nothing inside of them, Arduino will not let you run the program without them there. So make sure you always have those in there. You're also going to see that from time to time I may refer to your Arduino IDE files or programs as sketches. That's just some notation that Arduino has adopted. Okay, data types. Data types are key to understanding variables. It deals with memory and data storage. So a few common ones that you may have seen before or be familiar with is int, which is for whole numbers, float, which is for decimal numbers, char, which is a single character such as A or B or C, and then bool, which stands for Boolean, but that like true or false or 0 or 1. Each data type does associate to a different amount of memory. So for example, if you're dealing with an Arduino Uno, it's 4 bytes of memory. And this is different for each data type, so int and float and char. There's also another one called long. As you may be able to tell from the name, long has a lot of memory. But let's jump into just understanding what they are. So I'm going to use this bucket analogy. So say we have a bucket and it has a certain volume, right? It can hold a certain amount of water. We are going to put a label on this bucket and name it. Let's say, for instance, this is Buddy Bucket. You can name it whatever you want, but we have a bucket, it has a certain volume and a label. If you go over the volume of the bucket, right, it's going to pour out and there's going to be a mess and it's no fun. So the amount of water that you can store in this bucket is limited, it's finite. In programming, this is very similar to variables. So here we see that volume is highlighted blue and so is int. Int is our data type for the variable bucket size. Bucket size, also green to label, is our label for this variable. So when you're creating a variable, you first start with your data type, which in this case is int. This specifies how much memory is being allocated to this specific variable, which kind of, if you can think about it, means how much you can store, right? It's the volume. So we have our int our name, our bucket size, or a label, and then we're assigning the value of 20. This is completely arbitrary. This is just an example, but just so you get the idea. So here we have label is equal to bucket size and volume is equal to the data type. And in this case, int would be equal to 4 bytes. Okay. Let's jump in, before we go into conditional statements, some examples. So here I have a string called name, and here I have Brad. So the data type here is string, the label of the variable is name, and then what I'm storing inside my bucket, inside my variable, is Brad. You'll see that for string, you do have to enclose the words in these quotation marks, so keep in mind that type of syntax. But a different example would be this one, for instance. We have a variable called number. It's of type int, which means that we can store whole numbers, and that's why I assign it the value 8. I could not, for instance, store 9.14. It would round down, so it would actually be storing 9 instead of 9.14, and that might mess up your code. So just keep that in mind. If we did want to store 9.14, we can use a float. So here I have float, and then pi is equal to 3.14. That is a decimal number. Then for bool, here's an example. We have boolean, so it can only be true or false. This has to be either true or false. It cannot be like, I don't know, fun or a number or anything like that. You can, I believe in Arduino, you can store it as 0 or 1, but oftentimes it will use true or false. So in this case, the data type is bool, the name is ECE5 is cool, and we're assigning it the value true. So in memory, true is being stored, and it is of type bool. Awesome. Okay, let's jump now to conditional statements. We have if, else, and else if statements. These allow programs to make decisions based on conditions that you set for the program. You can execute specific code based on certain conditions, and you can also kind of, in a way, layer them. So you can say, like, if this happens, then do this. But if this doesn't happen, then try this first, and then so on and so forth. So here we'll see this is the syntax. We have if, and then your condition. Obviously, in your actual code, your condition will be specific, and we'll go through some examples, but this is just the general syntax of an if statement. You can also have an else if statement. However, note that you cannot have an else if statement without an if statement. You do need these brackets. This is a fun part of C++ and C, so don't forget those, and these parentheses around your conditions. Now, this else if statement will only execute if this if statement is not true. If this if statement is true, the computer will never execute anything in the else statement. So keep that in mind. And in addition to that, if you have an else statement under your if else statements, then this code will only ever execute if all other conditions above it were false. So also keep that in mind. But these conditions are up to you totally, and you can use logical operators such as and, not, or. You might have seen in, like, if you take ECE 25, and, not, or gates. So I'll show an example here about what that can look like. So here's a general if statement here, and an example could be, let's see, if x is greater than 5, execute my code here, right? So whatever code you wanted to do. That is an example of a conditional statement, right? So if x is greater than 5, and say before you have an int x is equal to 4, if this were the case, this is your whole code here, nothing would execute, right? It would not enter the if statement. But if, for instance, this was 6, then anything in the if statement would be called, because x, which is now 6, is greater than 5. You can also use, as I'll show here, here's an if-else statement. So you can say, like, if x is greater than 8, which right now it's not, do code here. But since it's not, we're going to skip this if statement, and it will execute here. That makes sense? So we have 6. 6 is not greater than 8, so nothing's going to happen here. But since there's an else statement, we will execute here. Okay, so now this is very similar to an if-else-if statement. You can also use the and, not, and or operators that I was talking about. So you can say if x is not equal to 5, then execute code, which in this case, this would execute, right? Because x is 6, not equal to 5. You can also do, let's say, if x is greater than 5 and x is, let's see, less than 10. So in this case, this is also true because 6 is greater than 5 and it is less than 10. These both have to be true for it to enter the if statement. Okay, and this is the same for or. Here's an or statement. And so 6 is greater than 5, or it can be less than 10. If in this case, let's say if it was less than 4, if this was an and statement, this would not execute, right? Because 6 is not less than 4. However, if we use an or statement, this will still execute because it's an or. So it doesn't have to be both. It can just be one of them, which in this case would be the x is greater than 5. Okay. Hopefully that makes sense. If not, go ahead and pause it, rewind it, maybe slow it down, whatever you need. You can also ask questions in class. Okay, let's go on to the next guy. Loops. So while in for loop syntax, loops are super helpful. They enable when you have like blocks of code that are repeating one after another. It can be really hard to, or really annoying to repeat those same blocks of code over and over again. So that's where loops come in handy. There's two types of loops that we'll be using, while loops and for loops. So this is the syntax for a while loop. Pretty simple. We have while and then your condition. So this will be very similar to our if and else statements. Here we say while true, which this guy, keep in mind, this will run forever. So just be aware, if you do put true in here, it will run forever, which sometimes you do want that, and that's okay, but just keep that in mind. But you can also have one that says like while x is greater than 5, right? So then if x is constantly changing, then it will run while x is greater than 5, and then once x is equal to 5 or less than 5, it will stop running. Okay, so now we go on to a for loop. For loops are a little bit different and they can be a bit tricky, but let's go through an example here. So here's the syntax. We have for, similar to while, and then in these parentheses are kind of your parameters. We have an int, so I'm creating a variable, int I. Here I'm creating a variable, so that's the first thing I do. Now I'm setting it to a value of 0. You don't have to do this part inside of the for loop. It's just kind of common practice, but you can entirely do it outside, such as here, and then it'll still work fine. Next, what I'm doing is saying loop the amount of times that it takes for I to get to I is greater than 5 or equal to 5, because here my condition is I is less than 5. So, and then for after each iteration, I want you to add 1. This is what that plus plus is. It's add 1. If you did a minus minus, this would be subtract 1. Okay, but I'm going to say plus 1. So let's go through an example. We'll say for I is equal to, okay, let's say serial print I, and then serial print next. Oh, wow. Next. There we go. Okay, so what will we be doing? Let's start with the first one. Because I is less than 5, I know that it will run 5 times. And you'll be like, that's not entirely intuitive, so let's walk through it. First, we say I is equal to 0. Okay, so I'm going to keep this little counter here. I is currently equal to 0. I is less than 5, and we're not going to add 1 yet. We're going to do that at the end. So I is equal to 0. I is less than 5. Now, because that's true, I'm going to serial print I, which is 0, and then I'm going to serial print next. Okay, we're done with the loop. Now we add that 1. So I is now going to be equal to 1. Now we go back to the top. I is now equal to 1. I is still less than 5. Now I'm going to serial print I, which is 1, serial print next, and then I'm going to add this 1, this guy here. So this happens at the end. So now, because we got through that loop, now I is equal to 2. And you're going to keep going and now say this is equal to 4. So 4 is less than 5, 0 print I, 0 print next, and then I plus plus, so we're going to add 1. I is now equal to 5. We go back up to the top, and now 5 is less than 5. It's not true. So now we're going to continue on. Whatever's down here, we'll move on, and the for loop is now done. Okay. Hopefully that makes sense. If you're still a little bit confused, we'll go over 3 examples in class, but you can also rewind, and there's plenty of examples I'll show you later on the Arduino documentation. So this is a really good resource. I'll go into a little bit more depth later, but it's at docs.arduino.cc, and I have a bunch of examples and documentation, and please feel free to explore there. Okay, let's move on. Yeah, so these are the 3 parts of your for loop. First, we call it the iterator, right? So what's going to be moving through the loop or changing through the loop. Then your condition, and then you're going to be either adding or subtracting by 1 each time. Okay, almost there, promise. Arrays. Array and indices syntax. So we use arrays quite often. They're great for storing elements of, and this is key, the same data type, okay? So if you have multiple elements and they're of different data types, say one's a string, one's an integer, one's a float, you cannot store that in an array. There are things that you can use to store that, and you can learn that later on in other classes or on your own time, but for our case, we'll just be using arrays. So they have to be all integers, such as like 3, 4, 7, all integers, you're good. Okay, so they are key for also managing and organizing data. That's why we use them. They're really, really nice. And you will also be using them for your LED strips. So hopefully you can drill this into your mind. Keep in mind that indices start at 0. It's not like English where we start when we count 1, 2, 3. Indices will start at 0, 1, 2, 3. So keep that in mind when you are using arrays, and it'll make a little bit more sense when we get to our examples. But let's first start with our syntax. So very simple, just look at this one line here. Here we have our data type. We learned about those. It can be int, float, boolean. Then we're going to have the name, the label, whatever you want to name it. And then the size. This is a little bit something new. Also keep in mind that you do have to put these brackets. They are required. They're not optional. And then the size is a little bit complicated, but sometimes it's required and sometimes it's optional. And the size is how many elements you have in the array. So this is kind of a little picture of showing you what an array can look like and what you might be able to visualize it as. And in this case, we have spaces for 1, 2, 3 elements. So the size here would be 3. And then this is what I was saying, where sometimes the size is required and sometimes it's not. If you have an array where you know the elements that you want to put in it, but you don't necessarily know the size, or you don't want to count them all, you don't necessarily have to put the size if you have elements stored in the array. However, if you have an array that has nothing in them, such as this line here, you have to put a size. You can also put the size when you are storing something in the array, but it's not necessarily required. The computer can count the amount of elements that you stored in that array. However, when there are the cases where you don't have any elements, the computer can't count because the elements aren't there. They're non-existent. So it needs to at least know how many spaces in memory to allocate to that array. So in this case, I have an array of size 3, and here's the indices, 0, 1, and 2. See how it starts at 0? So we don't count 1, 2, 3. We count 0, 1, 2. Okay, sorry about that. Okay, so we have 0, 1, 2, and then here I'm going to start assigning values. So this is how you can access our spots in memory. When I created this guy, such as here, say I have a data type int, I named it name, and it says size 3, the computer then stores in memory 3 separate integers, and right now we don't have anything stored there, but it has that space and it's ready to be occupied. So this is how we're going to access them. So name at index 0, we're going to store 3. So there we go, got our 3. Now name at index 1, we're going to store 4, and name at index 2, we're going to store 7. So that's how arrays work. Let's go into some examples though to kind of dive a little bit deeper. We have here a data type int, and we're going to name the array dogs. So here's the label, here's the data type, very similar to variables. Now the difference here is here's our size. We have the brackets here, and then it's of size 3. So this is all right. We don't know what dog we want to put in there yet, but we do know it's going to be 3 dogs. Now, if I were to do this, that is not allowed and it will not compile because the computer doesn't know how many spaces and memory to allocate. Now, if we go to this guy, here we don't specify the size, but we are storing something in it so the computer can count, oh, you need 1, 2, 3 spaces of memory. So that's okay. But here we have it of type string, and we're naming it again dogs, and we're going to store in index 0, lab, in index 1, poodle, and in index 2, pug. Cool. Okay. Now, last but not least, we have functions. Functions are incredible. They're going to save you a ton of time and also make your code a lot more organized, reusable, and readable for people if you're exchanging code or if you're working on a project together. They break complex tasks into smaller, more manageable tasks. So if you have like a project with a bunch of sensors, it's really helpful to use functions for that. And there are all 2 types of functions, or not really 2 types of functions, but 2 types of functions that you'd be using. One that's user-defined, so one that you make for yourself, and one that's part of a library, which we'll dive more into deeper. Okay, so going first into user-defined, we have the return type. This is a data type. It's the exact same as a data type, but we call it a return type because if you want a function, it's kind of similar to math where if you have an input, you do something to it, and then you have an output. Exact same as a function. Your input here is a parameter, and your output is going to be the return. And the return you have to specify, one, whether or not you have a return, and what type of variable it would be if you did return something. And we'll go into an example that's slightly complicated, but here's the overall syntax for it. And then this guy here, you might have seen it once or twice before. This is when you include a library. A library is a collection of functions that you're able to utilize. So right now, actually, in the Arduino IDE, we're using the Arduino library when we use things such as serial and print. That's part of the Arduino library, and void loop. But this is what you'd want to be using if you want to include a library and use the functions in that library. And we'll go to an example of that. And you'll also see this used when we go to our LED strip. We'll be using the fast LED library there. Okay, so let's go first though into user-defined functions, which is this top guy, and go into an example. Okay, here we go. We have this guy, void blink LED. So void, you've seen this before. You'll see it in void loop and in void setup. Void means I'm not returning anything. I don't want the function to output anything. I'm putting something in, or I'm not putting anything in, and I just don't want anything to come out. So that's what void means. I could have it be something else, and we'll get into that after we go through this example. Okay, so here's my return type, here's the name, blink LED, and then this is my parameter. I'm passing in a variable that is of type int. Now, it's slightly confusing, but let's say outside of my function, I have an integer called int LED pin, and I assign it the number 13. I want to pass this guy into my function that I have here. And this is what's called a function definition here. And then when you call a function, this is how you'd write it. If I want to use the function that I've made, which blinks an LED, I'm going to say blink LED and then just LED pin. Now, what is this doing? This here is first, the computer's going to be like, oh, okay, this is a function that I recognize. It's going to go down here. It says, okay, it's taking in one parameter, which is int pin. So I'm going to store whatever it passes into a variable called pin that's an integer. And here, LED pin is equal to 13. So really the computer, instead of seeing LED pin, which is just for your convenience, is seeing the number 13. So here it would be passing in 13, and then at every instance of pin, right? Remember this was originally int pin. At every instance of pin, this is 13. So at pin 13, I'm going to digital write it high, delay, and then digital write it low. Okay, so again, this is a variable. This is a function call, and this is a function definition. Okay, so this is how you define. You can think of it as a recipe. So this can be used over and over and over again. This, instead of passing in 13, we can pass in 14, and we can call it again afterwards and say LED pin. Either of these are both totally valid. This one is passing in 13, and then this one's passing an LED pin, which is 13. So this is how you use functions. Now let's go into an example that is returning something. So say I have the same one, but I want to return a number at the end. Say int pin digital write pin high. Okay, I'm gonna stop there, just kind of keep it short, and I'll put in a delay just for fun. Oops, there we go. But you'll see that instead of void, I put int, right? So this means that we're returning something. We're gonna put in an integer, which we're gonna store in pin, but then we need to return something. And just for example's sake, I wanna say that I'm gonna return a variable called int, let's say, count. Okay? So count is equal to 0. And let's say after I turn the LED on, I want to turn count is now equal to 1. And then I'm going to return count. Okay? So every time you use this function, it would return count, which in this case is 1. So if you were to call the function like we did before, where it says like blink LED, let's say 14, in this case this is fine, and you can still use this call syntax for this guy too, but because it's returning something, we typically want to assign it to a variable. So let's just call this output. And so now, once we run this line of code, output after this line will be equal to 1 because it's returning count, which is equal to 1. Okay, hopefully this makes sense. We will be going through functions a lot in our programming worksheet and workshop, so please take a look at them. Please dive deeper into the Arduino documentation if you have more questions or you're just curious. And yeah, you're all set. Thank you for listening, and make sure you bring your LED strip and ESP32 to our workshop. Have a great day.